This is section 5.5 for precalculus, and in this section we're going to talk about solving trigonometric equations, in other words, equations with trig functions in them. Okay, so these are the learning objectives. You basically have to use identities, you have to understand solving equations with multiple angles, etc. Make sure you read over those. The problem with solving trigonometric equations is there's no perfect formula to follow here like there were in section 5.3 where we had formulas for those problems. You need to use your algebraic skills to factor when you can, find a quadratic form when you can, etc. And you also need to find or recognize the basic trig identities to help you simplify the problem. So it's kind of like, let's put all of our trig and algebra skills together here to be able to solve these problems. And probably one of the more complicated sections, I understand that. I'm giving you examples, though, that are similar to what you'll see on the homework, okay? So in each example, we'll solve this over the interval 0 to 2 pi, not including 2 pi, because 0 and 2 pi are essentially the same angle. All right, so in example 1, we have cosine of x plus cosine of x times tangent of x equals 0. So in this first type of problem, just start using your algebra skills. The first thing you should notice is that I can factor a cosine of x out of that equation. So I get cosine of x times the quantity 1 plus tangent of x equals 0. Then if I have two things multiplied to give me 0, one of them has to be 0, or they both have to be 0, right? So this tells me cosine of x equals 0, or 1 plus tangent of x equals 0. So for the cosine of x equals 0, I need to understand the unit circle, or I need to make sure I just have a good grasp on the cosine function. That's going to occur at x equals pi over 2 and 3 pi over 2 in the interval 0 to 2 pi. And then solving 1 plus tangent of x equals 0, I get tangent of x equals minus 1. And for the tangent of x equal minus 1, I know I'm talking about a 45-degree reference angle, and tangent is negative in the second quadrant, so x would be 3 pi over 4, and also in the fourth quadrant, so x would be 7 pi over 4. So there's 4 different values of x which make this equation true in the interval 0 to 2 pi. Those 4 are pi over 2, 3 pi over 4, 3 pi over 2, and 7 pi over 4 if I list them in order from smallest to highest in 0 to 2 pi. Okay, for example 2, whenever you see a trig function squared and then the trig function not squared, the first thing you should probably think of is there a way for me to factor this into? And factoring is always going to be the case. So what I'm going to do is I'm trying to get it 0 on the right-hand side, so I want to bring over a positive square root of 2, so I have this. And then I'm going to do like when I factored, harder equations, where I look at the first 2 terms by themselves and then the second 2 terms by themselves. So in that case, I have a cosine of x and a 2. I can factor out of these first 2 terms. So that gives me 2 cosine of x, and then times cosine of x for this guy, and then 1 for this guy. So 2 cosine of x times cosine of x plus 1. That's factoring these 2 terms together. Now factoring these 2 terms together, I can factor out square root of 2. So I get square root of 2 times cosine of x plus 1 equals 0. Now what will tell you if this is the right path to go down is that these 2 terms now will have a common factor, and that common factor in this case is cosine of x plus 1. So cosine of x plus 1 is multiplied times 2 cosine of x in the first side, on the first term, and on the second term, cosine of x plus 1 is multiplied times root 2. So it's 2 cosine of x plus root 2 times cosine of x plus 1. Now I have a situation where I have something times something equals 0, so either 1 or both is 0. So 2 cosine of x plus root 2 has to be 0, or cosine of x plus 1 has to be 0. So solving for cosine of x, I get minus root 2 over 2, or minus 1 over root 2. That is an angle that we should be comfortable with. That should be a 45-degree reference angle, right, from our 45, 90s. So what quadrants is cosine negative in? Cosine is negative in the second, right, and the third quadrants. So the 45-degree reference angle tells me that x has to be 3 pi over 4 and 5 pi over 4 in the second and third quadrants. Okay, so cosine of x plus 1 equals 0 means that cosine of x equals minus 1, and of course that only occurs at x equals pi. Okay, so there are 3 places where this original equation is true in the interval 0 to 2 pi, and that's 3 pi over 4, pi, and 5 pi over 4. All right, as a third example, in this case, I'm not going to have 4 terms, right? So I have only 3 terms. When you see a trig function squared and then the trig function not squared, but there's only 3 terms, you should think of, is this in quadratic form? In other words, can I factor it just like I had x, just like if this was 2x squared plus 5x minus 12, how would I factor that? It's just that it's cotangent instead of just x. So that means I'm going to have a 2 cotangent of x and a cotangent of x to give me 2 cotangent squared x. And I'm thinking about factors of 12 where their difference can give me 5 when I'm multiplying it times the 2 and the 1, right? So the 4 and the 3 work, that gives me minus 12, and then when I multiply the outside and the inside, I get 8 cotangent of x and minus 3 cotangent of x, so that factors into these two terms, which means, again, something times something equals 0. That means the first something has to be 0, or the second something has to be 0, or both. So solving 2 cotangent of x minus 3 equals 0 tells me cotangent of x equals 3 halves, or since cotangent of x is 1 over tangent of x, tangent of x is 2/3. All right, where's tangent of x positive? In quadrants 1 and 3. Okay, so that means that x is the inverse tangent of 2/3. Okay, so when I'm solving that in terms of radians, I use my calculator in the radians mode. I get 0.5880. Why am I using radians and not degrees? Because I was told to solve it in the intervals 0 to 2 pi. That's radians. So I get 0.5880 to the 4th decimal place for that. That's not a common angle that we should know. It's not a 30, 60, or 45 or multiple of those, okay? So that's in the first quadrant, is 0.5880. And then pi units later would put it in the third quadrant. So 0.5880 plus pi is 3.7296. So those are the two different values of x that solve tangent of x equals 2/3 for x between 0 and 2 pi. And then likewise, I want to solve cotangent of x plus 4 equals 0. So cotangent of x equals minus 4, which means 1 over cotangent is tangent equals minus 1/4, right? 1 over minus 4 is minus 1/4. Where's the tangent negative? In the second and fourth quadrants. So x equals the inverse tangent of minus 1/4. If you put that into your calculator, that'll give you an angle in the fourth quadrant, but a negative angle, remember, because your calculator restricts it between minus pi over 2 and pi over 2. But to get the second quadrant angle, I take this guy plus pi units later, so it's 2.8966. And then to get in the fourth quadrant, I take the guy that's in the fourth quadrant but has a negative angle and add 2 pi to it to get 6.0382. So the 4 places for x between 0 and 2 pi are these 4 values of x that solve this equation. As a fourth example, in this case, I have cotangent squared, but I have cosecant. So I'm really not going to be able to think of this in terms of a quadratic form yet. But what I need to do is write one of these in terms of the other. So notice that from the Pythagorean identity, cotangent squared of x is the same thing as cosecant squared x minus 1. So then that tells me that I have cosecant squared x minus cosecant x minus 2 equals 0. That is now a quadratic form, which I can factor like this. Cosecant x times cosecant x gives me the cosecant squared. Factors of 2 are 1 and 2. So 1 and 2. Now where do I need a minus sign? With the minus 2. I need it with the 2 to give me minus 2 cosecant x plus cosecant x to get minus cosecant x. So that's the proper factorization. So something times something equals 0. That means the first something has to be 0. Cosecant x plus 1 equals 0. That means cosecant x is minus 1. Cosecant is 1 over sine, so sine x equals minus 1, which is only at x equals 3 pi over 2. Cosecant x minus 2 equals 0. Cosecant x equals 2. That means 1 over sine, cosecant x is 1 over sine x, so sine x is 1 over 2, or 1/2. Sine of x is 1/2. Sine of x is positive in the first and the second quadrants. That's a 30-degree reference angle, so x would be pi over 6 and 5 pi over 6. So those are the 3 values of x in the interval 0 to 2 pi that solve that equation.